All right, guys, welcome back. We're going to be using the unit circle to work on some inverse of trigonometric functions. This is going to be something that you're really going to have to practice and to grasp. I think a lot of people are going to have a little bit of confusion, but the more you practice anything, the better you will be at it. So the first thing is first, let's talk about an inverse and what it is. So inverses, as we've done before, you switch the x and the y variables, and then you work backwards to solve for y once again. So for example, it says to find the inverse of y equals sine x. So if I switch those signs and I write x equals sine of y, in order to get rid of this sign and make it just y, we would have to do the sine to the -1, which is the inverse of x is equal to y. All right, this is also the same, and I have to make sure I stress this, is the exact same as arc sine of x equals y. All right, you will see it written either way. Do not get confused that they are the exact same thing. All right, arc sine, sine to the -1, those are the exact same thing. All right, so you'll always switch the x and y, use inverse operation to solve for y. All right, and this is why I have this kind of highlighted as super important. You need to know that these are the exact same because you'll see them both different ways. And I don't want you to get worried and be like, oh, well, I found sine of -1. It was this. Well, what is the arc sine? It's the exact same thing. So you'll see it written both ways. All right. However, what you do need to realize is that the inverse of sine is not equivalent to 1 over cosecant. All right, 1 over cosecant is sine, so it's not going to be sine to the -1. All right, this is a picture that is going to help you as we work these examples. So I'm going to get right into it, and it's going to show you exactly why this is important. This is the unit circle. When you are using cosine, you will only use quadrant 1 or 2 here. You will basically stay on the top half. You will never come down here. And again, you'll know exactly what I mean when we are working these examples. And then for sine and tangent, you will only use either like a positive quadrant 1 or negative quadrant 1. We're not going to call this quadrant 4 because we're not going to use the variables that are in quadrant 4. But if it were like negative pi over 6, we would use that. We would never use 11 pi over 6, all right? So that's going to make sense here in just a second. I'm actually going to write that here. Positive quadrant 1 or negative quadrant 1. We will never use quadrant 4 information. All right, we will only use the negatives of quadrant 1. Okay, and that will make sense when we revert back to the graphs on the second page, but we're going to do this page first. All right, so we're going to try some examples. We have to think backwards. So they are giving you 1/2, and they are saying that at what measure is sine 1/2? Now, again, for sine, we can only use the positive and negative quadrant 1. We will not go anywhere else. So sine is represented by the y value. We are looking for where y is 1/2. Now, technically, y is 1/2 here. But if you keep going, you're like, well, I could use pi over 6, 5 pi over 6. But we cannot use 5 pi over 6 because we are not using quadrant 2 for sine. And this is where this is going to come the most in handy. You can only use basically quadrant 1 or negative quadrant 1. And so in these two quadrants, the only one with sine of 1 over 2 is pi over 6. And that's going to be our answer here. So for these inverses, we're working backwards. They're saying that the sine is equal to 1/2. That's how you can think of it, rather than just what is the sine of 1 over 2? That's not what they're saying. The sine is 1 over 2 where? So y equals 1 over 2 at what location? All right. And so we're going to look at the same thing here. We have it written as arc cos. I have no idea what that is. Well, it's cosine to the -1. All right, so there, and we know that on the unit circle that cosine represents the x. So where For cosine, we're only going to use the top two, right? Quadrant 1, quadrant 2, where in the top two quadrants is our x value, negative square root of 2 over 2. We don't have a negative square root of 2 yet. Oh, and that's where it is. So we have it right here. All right, and that's going to be at 3 pi over 4. And that's going to be our answer. So we're working backwards. They're giving us the answer, and we have to go find the location of where it's at, rather than them giving us the location and we have to find the answer. All right. Let's move on to number 3. We have the tangent -1 of negative square root of 3 over 3. So where is tangent equal to negative square root of 3 over 3. Now, last unit, I created a tangent chart. If you still have that, that's going to come in a lot of handy for you. I will go ahead and say I know that the answer is going to be down here. It's going to be square root of 3 over 2, comma, negative 1 over 2, which is the y over the x is equal to negative square root of 3 over 3. However, we cannot use 11 pi over 6. We cannot. It has to be negative of the quadrant 1. So if we were to go backwards here, this is pi over 6. This would be negative pi over 6. All right, we cannot use the measures given in quadrant 4. We just have to use negative versions of quadrant 1. All right, let's move on to number 4. We have arc sine of -1. Uh-oh, that is sine -1. So that means where, and since we know that sine is the y value, where is y equal to -1? And since it's sine, we can only use positive quadrant 1 or negative quadrant 1. So we have to find where our y value is equal to -1. It's going to be down here. So technically this is 3 pi over 2, but if it were flipped, again, we have to use our negative quadrant 1. This is going to be negative pi over 2. So we would just take the top and flip it down. Where y is -1 will be negative pi over 2. All right, they're going to get a little trickier here. So we have to find the inside first and then use it on the outside. So where is our cosine equal to 0? And that's the x value. So we have to find somewhere on this top part, our x value is 0. Boom. That'll be pi over 2. All right, so cosine -1, 0 is equal to pi over 2. Now we have to find sine of pi over 2, which is the y value, which is just going to be 1. All right, so that we kind of had to combine two different steps, but those will get easier again as we go. So we have sine -1 square root of 2 over 2. So we have to find somewhere in positive quadrant 1 or negative quadrant 1 where y is equal to square root of 2 over 2. All right, that's the first step. And that's going to be up here. We have our y equal to square root of 2 over 2. That's at pi over 4. All right, so this middle center part is pi over 4. And then it is tangent pi over 4, which is y over x. Y over x. We have the same thing over itself. That's always going to be equal to 1. All right. And that is the first one. We're going to move on to the next page.